Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue our lesson about electron configuration. Today we're going to study the noble gas notation, and our objective for today is to use the noble gas notation to represent the electron configuration of an atom. So basically, our lesson focused today on using the noble gas notation. We need to understand what noble gas is and how can we use it as an electron configuration notation. Before we start, I recommend you guys, if you haven't watched the previous video about the rules, how we do the electron configuration, I recommend you to go back and to watch it. We studied something called the sublevel diagram, and this is the sublevels. These are the sublevels. We have when n equals to 1, we have only one sublevel, which is 1s. N equals to 2, we have 2s and 2p. When n equals to 3, we have 3s, 3p, and 3d. But if you remember that the 4s, it has lower energy than 3d. That's why, according to Hunt's rule, we fill 4s before 3d. And what I suggest you guys, I always tell that to my students, is that to write this diagram on a piece of paper before you start solving the questions from the exam. So how can we write it? It's very simple. You can write n equals to 1, we have only 1s, and when n equals to 2, we have 2s and 2p. When n equals to 3, we have 3s, 3p, and 3d. And when n equals to 4, we have 4s, 4p, 4d, and 4f. Then we continue in 5 and 6, and we only have 5f, 5, 6, the last sublevel. So then we're going to start doing the arrows. We start always with the lowest energy, that is 1s, and then 2s, 2p, 3s is before 3p, 4s, so 2p, 3s, and then after 3s comes 3p, 4s, and then 3d, and then 4p, and we continue. This is how you guarantee that you will never make a mistake doing the electron configuration. All right, now, for example, we have this table. The hydrogen, the atomic number of the hydrogen is 1. That means we have only one electron in 1s. The helium, it has 2 electrons, so also 2 electrons in 1s. That means for the hydrogen is going to be 1s1, for the helium 1s2. For example, for the boron, it has 5 electrons, so I'm going to write 2 in 1s, 2 in 2s, and only 1 in 2p. That is 1s2, 2s2, and then 2p1. Let's do it, for example, for the neon now, which has 10 electrons. So 2 in s, 1s, 2 in 2s, and in p, single, 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 and then we double those electrons to have the 10 total electrons. 2, 4, plus 6 is 10 electrons. And the electron configuration should be for the neon is 1s2, 2s2, 2p6, and that's it. 2 electrons in 1s, 2 electrons in 2s, and 6 electrons in 2p. Now, look at this. Helium is one of the noble gases. Neon is also one of the noble gases. What do you mean by a noble gas, and how we use the electron configuration or the noble gas notation? The noble gas configuration of an atom, it consists of the symbol of the last noble gas prior to the atom, followed by the configuration of the remaining electrons. And the noble gas is an element or the elements in the last column, that means in the last group of the periodic table, and they always have 8 electrons in their outer shell. They are unusually stable. We call them inert because they never react. They are very stable, those noble gases. And they have 8 electrons in their outer shell. It means 8 valence electrons. This is the group 8 or 18. And all of them, they have 8 valence electrons except for the helium, which has full outermost shell, which is 2 electrons. Now, again, how can we use the noble gas configuration? We need to write the symbol of the noble gas, the one prior to the atom that we are writing the electron configuration for, followed by the configuration of the remaining electrons after we write the noble gas. So for example, He, between brackets, as you can see, it represents the electron configuration of the helium, which is 1s2. Neon is 1s2, 2s2, and 2p6 because neon has 10 electrons. Argon, it has 18 electrons, so it's going to be 1s2, 2s2, 2p6, 3s2, and 3p6. So, for example, what do you mean by the prior? The noble gas that is prior to the atom. For example, if we are talking about the beryllium, so the noble gas prior to the beryllium is going to be the helium. So if you write it, it's going to be beryllium, Be, it's going to be 1s2 and then 2s2 because it has 4 electrons. But 1s2 is the helium atom. So I can write beryllium like this, between the brackets, helium, and then what is left, because helium is 1s2, what is left is 2s2. Now, how can we find this number? This number is the number of the period where the element is. So for example, the beryllium is in period number 2. So it's going to be 2s2. For example, if we're talking about the sodium with 11 atomic numbers, so it's going to be 1s2, 2s2, 2p6, 3s1. And 1s2, 2s2, 2p6, this is the neon, leaving 3s1. Let's check the periodic table. Sodium is in group 3. So yes, it's going to be 3s1. That is 10 electrons plus 1 is 11 electrons. Let's do it, for example, for the aluminum, which has 13 electrons. So 1s2, 2s2, 2p6, 3s2, 3p1. Here I have the neon. So I'm going to write neon and then 3s2, 3p1. As simple as this. For the chlorine, we have 1s2, 2s2, 2p6, 3s2, 3p5. That is the neon again. So I'm going to write neon, and what is left is the 3s2 and 3p5. 3s2 and 3p5. Argon, it's another noble gas which has 18 electrons. This is the argon. So it's going to be 1s2, 2s2, 2p6, 3s2, and 3p6. If you check now the argon, this is a neon, and this is what is left. So for the argon, I can also write it neon, 3s2, 3p6, or I can write it argon Ar. Very simple. That is, what is left is 0 electrons. Let's have some practice. Write the ground state electron configuration for the following elements. Bromine. And the bromine, it has, from the periodic table, it has 35 electrons. So instead of writing 1s2, 2s2, 2p6, that's a waste of time. So bromine with 35 electrons, I need to check now which noble gas is prior to the bromine. 35 is going to be also the argon. So I'm going to write argon Ar, and that is 18 electrons, but we have 35 electrons. So, and the bromine also is in period number 4. So I'm going to start with 4s. Now, 4s2. And what comes after 4s from this diagram, as you can see it, 3p, 4s, and then 3d. So after 4s, I'm going to write 3d here with 10 electrons. That makes it 18, plus 2 is 20, plus 10 is 30. After 3d comes 4p, and we have 30, so 4p5. Again, 4s2, 3d10, 4p5. The outer shell electron, the outer shell level is number 4, and we have in number 4 we have 2 plus 5, 7 valence electrons in the outer shell. So 7 valence electrons, and it makes sense because the bromine is a halogen. It's in group 17. That means it has 7 valence electrons. Let's do it for the strontium Sr, and this is the strontium. It's right here with 38 electrons. So if I'm going to write it, it's going to be also argon, because no, this time it's going to be the krypton, the prior noble gas for the strontium. So it's going to be Kr, and Kr, it has from the periodic table, it has 30 electrons. We need this is 36. So for the krypton is 36. This is 38. So Sr 38, and this is 36. Sr in which group? Is going to be in group number 5. So I'm going to start with 5s. So 5s, this is 35, 2. Because here in the krypton we have 36 electrons, and 2 electrons is left to make them 38. Last question. Chlorine atom is in its ground state. Here there is typo error. Has a total of 7 electrons in the orbital related to its atom's third energy level. So we have the third energy level, we have 7 electrons for the chlorine, Cl. How many of these electrons occupy p orbital? So we need to write the electron configuration for the chlorine. So I'm going to write 1s2, 2s2, 2p6, 3s2, and 3p5. Because chlorine has 17 electrons, as it says. All right. How many of the 7 electrons occupy p orbital? So we need to look at all the p orbitals. We have 6 electrons in 2p, and we have 5 electrons in 3p. That is 11 electrons in p orbitals. All right. Now, the second question, how many of the 7 electrons in a chlorine atom occupy p orbitals? Now here we are talking about the 17 electrons. So this is the answer. The 11 electrons is the answer for the second one, because here we are talking about the 17. But here, how many of the 7 electrons? The 7 electrons in the outer shell. So those are the 7 electrons. And we only have in the outer shell 5 electrons in 3p. So it's going to be 5 electrons here. And here we have in the second one 11 electrons, because 5 and 6, 11 electrons. So the electron configuration is very simple. Using the noble gas notation is also very simple. I want you guys to pause the video before we finish. Practice for the phosphorus, do it for the sulfur, and do it as well for the magnesium. I hope you guys learned something new today. Have a good day. Bye bye.